Okay. Honors geometry.
No.
Wednesdays we wear pink. Identify and use properties of similar triangles. Section 6.5. Was that you, Taylor? I'm guessing so.
There's a couple of other things on there.
My goodness.
What did you just say? I don't know. Did anyone speak Taylor? Because I don't know what you just said.
Simone, please comprehend for him.
Sorry, I don't speak stroke victim. I don't think anyone else really cares.
Grade it. Stop. You're being rude.
Oh, you spell Cosmo with an E?
Yes.
The one who told Justin to shut up for wearing.
Okay.
He looks like a mini Justin Bieber, but who has shaved head.
Okay. No, Taylor, what are you saying? Did you do this?
I did, but there's also something else.
What do you do?
Oh.
Did you read the 6.4 above it?
There's another thing after that.
What? Oh, no, that's actually right.
What are you supposed to be looking
Not
at?
Christmas time.
Did she erase the last
What am I supposed to be
Is
looking
it this
at?
one?
No, I didn't erase that one.
Well, that's gone.
There's an X. I don't know if you noticed that.
There is an X, but there's something besides that. That one wasn't that major.
Mr. Costle, I have things to learn today.
So do I. I have things to teach.
Mr. Costle, what's tomorrow's date?
Oh, okay.
Oh.
Oh.
Oh, 22.
Oh.
Why did you do 22?
That was like so stupid subtle. Anyway, I was like really confused. Like, did somebody write this wrong?
Wait, can you at least fix the line?
No,
No.
keep it.
Leave it.
There's one with a missing line and one with an X.
What does that mix in line? It's supposed to have words in it.
I did not, in fact, erase that one. I was just trying to hide from Miss Rodriguez, so I came in your room and changed stuff.
Not the two.
Wait, why were you hiding from Rodriguez?
That part doesn't matter.
What did you do?
Failed the test?
I did not fail a test.
On the test.
I haven't even taken the test.
There we go.
Dude, same. It's been like 3 weeks.
Congruent polygons.
If you took this, give you 100. That would do it.
Congruent polygons
Oh, crap.
have the same side lengths, right? That's something we know. Congruent polygons do in fact have the same side lengths.
That's not too good.
Okay, that's not new to us. They also have all the same corresponding angles, right? The same corresponding angles and the same corresponding side lengths. Okay, flip the page.
No.
Do it anyway.
You're so
Okay. Similar polygons. We're going to learn about similar polygons today, which is in fact section 6.6, 6.5. I'm all confused. Section 6.5. It's your fault. Okay. They have the same angles. They have the same angle measures. They have the same angle measures, but they can be different side lengths. So similar polygons have the same angle measures. Their corresponding angles are congruent, but they can have different side lengths. So for the similar polygons, corresponding angles are congruent. And then the ratio, hey, there's ratios coming in
Oh, no.
of corresponding sides are equal. That's why they're ratios, right?
No.
Okay. Ratios of corresponding sides are equal. Well, who's giving you the L?
You.
So you're taking the L?
Where's my card?
Slumpy. Oh no. You realize what's happening. That's probably the best. That's a highlight of that right there for me. Huh. Oh no. Okay. So if we do a ratio of the corresponding sides from these triangles, there's one triangle that's smaller than the other, right?
Yes.
Okay, which one's smaller?
See.
Okay, triangle ABC, the one on the left. Okay. So if I were to do, let's say I just do the small triangle to the big triangle, just for grins and giggles. So I do the small triangle to the big triangle. We said we can do ratios as a fraction. So let's make a ratio of these side lengths as a fraction with the small triangle on the top, the big triangle on the bottom. Let's do the small triangle to the big triangle.
James.
Because we're told that the triangle ABC is similar to the triangle DEF. Not yet actually, but I like what you're thinking, okay? We're just going to do corresponding sides. We're going to do corresponding sides. So if I were to say the side length of 3, what would that correspond with? The side length of 6. Side AB corresponds with side DE. Okay? What else is this? What else would be a pair of corresponding sides? 4, 2, 8, and 5, 10. Now are all these ratios equal? Yeah, they all equal what? 1/2. 1/2 is equal to 1/2 is equal to 1/2. So the ratios of corresponding sides are equal. My pen drags because it didn't look up. It's just how it happens. Okay? The ratio of corresponding sides are equal. So the corresponding angles have to be congruent, but it's like you took this triangle and you just made it bigger. You stretched out every part of it equally. Okay? It's not like a Microsoft Word when you go out and you just stretch it one direction and it looks all wonky. You stretch it diagonally so it stretches proportionally. Yeah, it's kind of like you zoomed in. Okay? That's another way to think of it. Okay, you don't just stretch it one way. Okay? What's up?
Can you do the worm?
No, not well.
You try.
But you can do a dab push up, but you can't do it.
Yes. You can also do behind the back flap.
Oh, wait, no. I can do the worm. Oh, what?
Behind the back flap.
What? No.
I tried to get a student advisor for the first time.
Show us.
Okay, I'm for team.
Wait, I want proof.
Maybe there. Okay. So this is true for our similar polygons. And we're going to practice a lot with similar triangles. So for this figure above, the figure above in your notes, it's on the previous slide though, we can write a similarity statement and a statement of proportionality. So like if you had a congruent statement. Okay.
Can you tell me we're
Yes.
not doing proofs again?
You serious you're doing proofs?
I never said we were, I was just asking.
So our similarity statement can be triangle ABC is similar. Now for similar, we just do the tilde. For similar, we just do that little tilde. Okay? Triangle ABC is similar to triangle what? Who can help me out? For the one up above.
DFF.
DEF.
What?
DFF. Okay? Triangle ABC is similar to triangle DEF. We have to make sure they're in the same order again, right? They have to be corresponding order just like we did with triangle congruence. Okay? And our statement of proportionality is what we can do with the side lengths. So if I were to do side AC to side DF, those are proportional. Side AC to side DF are proportional. Okay, yep, segment. Right.
No, can I do the thing where it's like AC to DF?
If you really wanted, we're going to be using fractions a lot in this, so I think it'll be easier. Okay. This is equal to the ratio of CB, side CB over side FE, which is also equal to the ratio of what side over what side?
I'm sorry, what is that?
CB over FE. FE.
What? That's no AC.
Oh, DF. Sorry.
Is there a line on the
Yeah, that was excellent. Okay. Yes. Okay, AB to DE. I heard that said a couple times, so thank you. AB to DE. Okay. Okay. And that's the same thing we just did a second ago with these fractions, isn't it? We're just actually putting in the sides instead of the side lengths. And we're saying it's true. And we just went out and said ahead a second ago and said, oh yeah, you all equal 1/2, so they are all equal to each other. So this is what we call a statement of proportionality, of stating, oh, the corresponding sides are in fact proportional. We can put the ratios with the equal sign, so they are in fact proportional. Questions on that?
No.
Okay. So here's an example of these triangles. And we're going to see if they're similar. So we're going to list the corresponding sides. We're going to list the corresponding sides here. So what are the corresponding sides? Somebody give me a set of corresponding sides, a pair of corresponding sides. Okay, side DE and side AB, awesome. Okay, somebody give me another pair of corresponding sides.
BCEF.
Okay, side BC and side EF, great. Somebody give me another pair of corresponding sides. Okay, DF and AC, very good. Now we can ask, what is the ratio of corresponding sides? Oh, 6, 6, 7. I just did that last hour. So,
No, I think he's in there.
Alright,
I was gonna say whoever was employed, whatever it is, it wasn't me.
what is the ratio of corresponding sides? Okay, so now we can actually make a ratio with the numbers. So you can help me out with this one. Okay, 15 to 5. Okay, what's another ratio of corresponding sides? And let's go ahead and since John, let's start with the big triangle on top. She's doing big over small. Let's continue with that big over small for this one. Doesn't matter which one you do on top. Once you start one on top, you have to keep going. Sarah,
36 to 12.
hit 36 to 12. Okay, great.
30 to
30 to 10. Okay. So if you're, and then yep, we would like to simplify. 15 over 5, let's simplify to
10. 1 over 3, 1
1 over 3, or 3 over 1, excuse me.
It's
So
all
3. 36 over 12.
3
3 over 1 or 3. 30 to 10.
3.
3 over 1, 3. So we get 3 for all of these, or 3 over 1 for all of them. And this is what we call the scale factor. This is what we call the scale factor. So we're saying from this big triangle is 3 times as big as a small triangle. We take every small side, multiply by 3 to get to the big triangle. Okay? So we take every, no, it doesn't look like it. Alyssa. Yep, you can also say it's 1/3, depending on if you're going, whatever you're saying, whether it's big over small or small over big. That would depend. That would change whether it's 3 over 1 or 1 over 3. Exactly right. Like on my notes, I actually have 1/3 because I have it going small to big. Jocelyn started us off going big to small, so I said, hey, let's keep going. It doesn't really matter. It's a great question. As long as you have kind of this written, people will know what's happening there. Okay. And what kind of happens, guys? The scale factor, it's like things being done to scale. Where have you guys seen like this is like not to scale or to scale? Where have you guys heard that before?
In the rear mirror.
Okay, in the rear view mirror.
Or side mirrors, not
Okay, side view mirrors, get objects are close and they appear. Okay, when something's like drawn to scale, okay, what's that usually mean? Is it normally the same size? No, it's a lot smaller, right? Something is drawn to scale, make it a lot, or not drawn to scale, they usually is drawn a lot smaller. Like if you're drawing a building, it's probably not going to be drawn to scale. Or it's probably not going to be drawn, excuse me, actual size. That'd be massive. Okay, what?
You're not going to target the thing actual size.
Probably not. Okay, so you're probably going to print a scale model. And when you print your scale model, or you draw your scale model, okay, are you going to want like the doors to be the same size as the doors would normally be, but then everything else is shrunk? No, you want everything to shrink accordingly, right? So you want to scale everything. So just like here, we don't just scale one side and just make 5/15, the other ones are still 12 and 10. You can scale every side. Okay? So those angles have to stay the same still. Those angles have to stay the same. Because they still have to add up to 180. So we can't take the angles and start multiplying and dividing, because then we would have a different number than 180 is what they add up to. And then we no longer have a triangle. Does that make any more sense? So, okay. So this means that we can say the triangles are similar because all this, the ratio of the sides is equal. The sides are proportional, so to speak. Now I can say, what is the ratio of the perimeters? So we can find the perimeter of one and the perimeter of the other, and we can take the ratio of that. So perimeter we said is what?
All
Yeah, it's the distance around the figure, so you add up all the sides. So what's the perimeter of this big one? Perimeter of the big is equal to 71? 81?
I can't add my butt, Johnson.
You can't
Sorry,
add your
that-
butt.
Okay.
What's the perimeter of the small triangle?
27.
27. What do we notice about 81 compared to 27?
3 times as small.
is 3 to 1, isn't it? Is that the same scale factor?
Yes.
No, that's the same as the scale factor. So, our perimeters are also affected by the scale factor. Our perimeters are also affected by the scale factor. And if we actually look into the math behind it, it makes a lot of sense. Once we look into the math behind it, it makes a lot of sense. Okay? Because if we were to take this the perimeter and divide by 3 or multiply by 3 depending which way we go, and we would divide or multiply by 3 depending which way we go, big, small, small, big. Or if we first just divide all these by 3 and multiply all these by 3. For example, if I were to take 5 times 3 plus 10 times 3 plus 12 times 3 and add them together, I'd get the perimeter of the big triangle. So I multiply each of the sides by 3 and then add them together. It's the same thing as taking 5 plus 10 plus 12 and multiplying by 3 because like you factored out a 3 out of everything. So by factoring, there end up being mathematically equivalent, which is why the perimeters are also affected by the scale factor. Pretty neat. Factoring. Okay. Nobody's excited about that as I am. That's also great. Any questions over this? Yes. Okay. So, are congruent figures also similar to each other? Well, let's talk about it.
Why'd you shout that?
I showed it at you. I showed it to you. Is talking to people, talking at people the same thing?
No.
Thank you guys. Nice, some people in here are reasonable. If you're talking to somebody, you're having a conversation with them. If you're talking at somebody, then it's really just a one big conversation.
But that's how this is going.
You're talking back. That's tough.
Only for forcing my way into it. None of you are forcing your way into it.
Because I don't care enough to force my way into it.
Yeah, but I'm trying to not get yelled at.
You think
I
Mr.
tried
Coffee
to-
is gonna yell at you?
He just did. That is what happened.
That really me
Do you really must have an odd definition of yelling?
It was like so chill. It wasn't.
That was more of like a stern Mr. Cossel talking to.
That
So
wasn't
you
even
clearly have
stern.
never been yelled at in your life.
I yell at people all the time, okay. So let's look at these two triangles. Okay? Are these triangles congruent?
Yes.
Yeah, we know all the corresponding angles are congruent, all the corresponding sides are congruent, okay? We can see that. So for similar polygons, we say that we need all the corresponding angles to be congruent. Are the corresponding angles congruent?
Yes.
Okay, so the angles are congruent. And then we also said, for similar polygons, we need the ratios of corresponding sides to be equal. We said the ratios of the corresponding sides to be equal. What up, bars? Guys, we're raising the bar in here by 2. Okay?
Oh.
Oh. Did you go to the dentist? Why'd you-
Thank you. Thank you. Yeah. Yeah, bonus points for most of you imaginary.
That's
That's
you.
so-
Yeah, the top link.
I got
No. That comes last. We're answering the question, and this is how we answer the question.
And why is it first?
So we can think about the question.
No. No.
You can not like it all you want, but I don't care. I care about you, but I don't care that you're frustrated with that because I'm going to keep organizing my eggs and like the way it's organized. Okay? So anyway, we said for triangles or polygons to be similar, we also need the corresponding sides to be equal. The ratio of the corresponding sides to be equal. So if we take this triangle, let's just say we take the triangle on the left over the triangle on the right this time. We don't really have a big and a small. Let's say we take the left over the right. So can somebody give me a ratio of the left side to the right, left triangle to the right triangle?
4 to 4.
Okay, 4 over 4. Somebody give me another one.
5 to 5.
5 to 5. Somebody get another one. 3 to 3. Actually, I think this one's backwards, guys. Okay. Anyway, what do those all simplify to? 1. So is the ratio of the corresponding sides equal?
Yes.
Yeah. So, according to our definition of similar, are these similar?
Yes.
Yeah. So your figures are also similar. So to answer our question from earlier, going back up to our thinking question, okay, are congruent figures also similar to each other?
Yes.
Yes. And what's the scale factor of these, though? What's the scale factor of these?
One.
Yeah, the scale factor just happens to be 1. It's a 1 to 1.
One to one to one.
I know. Okay?
Can I just write SF?
Just wanted to make sure I didn't see what so
What?
I just wanted to make sure it was on your desk, the notes. I didn't see them. Then I looked over and I saw them.
Have more faith in me.
You what?
Have more faith in me.
You're right. That might be. What's your sticker?
Trust.
Oh, nice.
Maggie, where's your sticker?
I think it fell out of my pocket.
Oh, that's...
I know.
Did you drop your pocket too? Continuing on.
You're so chill about that.
Next page. Not the first one.
I did deal with this last year too. This is not great.
What? Okay. Determine whether the polygons are similar. If so, if they are, write a similarity statement and find the scale factor. Determine if these polygons are similar. If they are, write a similarity statement and find the scale factor. I want you guys to take a second and think through these. Think through this one. See if you can figure it. I'm sorry. Think in your head.
Hit the
Not thinking out loud.
Are you okay?
I haven't seen the Trolls movies. Are you good?
Yes.
Not really.
What?
Evan's giving me an aggressive no. Evan, this might be the most emphatic I've ever seen you about anything, so I feel like I have to trust your opinion.
Yeah, it's not that good.
What do you mean? I love that one.
It's not good.
Pretty
It's
sure
not
you
good.
It's what?
The only location that we have the CIA black site is get information.
I don't think I've ever heard him talk besides for now.
Me and Evan talk all the time.
Just want to say.
I love it. Alright. Anyone have any thoughts on this and whether the polygons are similar?
They're similar.
Okay, I hear some aggressive no's. Someone tell me why not then. Okay? Creative.
Because the scale factor is not cool.
What do you mean?
Mind you, it would be a normal number.
Sorry. What was that before that? What?
Doesn't scale right.
Okay, it doesn't scale right. Explain how did you get your 0.83?
Well, when you do the other ones, you can just divide.
So what did you set up here?
Like half divided by 6.
Okay. Okay. And then did you set up anything else or just this? Okay. So we would need then the ratios to be equal. So what else would we need to do to prove the times? Harley?
Well, I realized that the angles are different.
Okay, I'm gonna actually back up and have you set 45 seconds a minute. Okay? Great.
So you have to scale 4 over 3.
We do 5 to 6 and we have to do
3 over
3
4.
over 4.
That's 75.
Are the ratios equal?
No.
No, so we can know they're not similar that way. So we know they're not similar that way. Okay? Even though 5 to 6 and then the other 5 to 6 would obviously work. Because it's the same. 5 over 6 is still 0.831. Okay? Okay? Now there's another way we can know they're not similar. Carly, the angles are different. Are the corresponding angles even congruent?
No.
No! So we don't even know that. Okay? That's another way we can know they're not similar. Okay? We can say corresponding angles
I would.
not congruent or not congruent.
What were you winning?
Everything.
He just likes to feel like he wins. Okay? Just let
Yeah,
him
okay. I don't
That's
like
what I
to win,
do.
alright? So I need this. Now leave me alone.
No.
Why are you so aggressive about everything?
B, aggressive. B, aggressive. B, R, E, I, V, E,
Don't
aggressive.
encourage him.
Can I try out next year?
I
This
think
year?
yeah, sure.
Any
Yo,
questions?
imagine Mr. Costa as a cheerleader.
He's gonna be a cheerleader.
I want to see him in show players.
Okay. Alright. Find the missing side lengths of the triangle in each problem if the triangles are similar. Find the missing side length, missing length, if the triangles in each problem are similar.
I don't
Now we're going to say these matching dots are also going to be congruent angles. We're We're starting off with the doozy, actually. I should really order that one later.
Yeah. I don't like that one. Can we just label that one?
Just.
Okay, let's start off with letter B, actually. Okay. So we have these two triangles. These corresponding angles are congruent. These angles are congruent. So these angles must be congruent, right?
Yeah.
Okay. And we're told that the triangles are similar. Saying if the triangles are similar, so we're saying they are. So can we figure out this missing length?
Yeah.
How?
You put 5 over 15,
Find scale and scale it up.
It's a
5 over 15,
and then simplify it,
and simplify it, that is
1/3.
1/3. So how do we go from there?
And then you do that with 4. You do 4 times 1/3.
You do 4
12.
times 1/3.
Or wait, is it maybe divided?
4/3. Is this 4/3?
No,
No.
you would
No.
you would divide it, but you would technically multiply it by.
Oh, but you would okay, yeah.
Okay, we divide it, but we technically would multiply by 3, right? From 5 to 15, multiply by 3. So from 4 to D, we multiply by 3, the same factor.
D equals 12.
And we get 12. 12 what?
Meters.
Meters. Okay?
That was not
Can anybody think of a way we could do this using a proportion?
No.
Oh, God.
Using a proportion.
No.
Oh, no.
No.
What if I
Wait,
did?
no,
I'm
no.
going to help
You
us
know
think
what,
of this.
Adrian?
Oh, yes, we did do proportions.
What if I did 5 over 15
No.
is equal to
Stop.
blank over blank? What do we think it could be?
4 over it.
4 over
Or, yeah, 4 over
4 over
D.
D.
Stop.
Could we then solve this right
No, no, we
I'm
can't.
not gonna
No,
lie,
we
I
can't.
actually.
We can't.
Wait,
Shut
wait.
up.
I think
We can do it.
proportions
Shut
is a
up.
lot.
Hey, listen up.
I feel like proportions is a lot easier because we've already done this before. Like it's not. It's not.
Yeah, but I didn't understand it the first time we did it, so why are we doing it a second
Then why
time?
did you not get help?
So you can continue to learn it.
Why are you so cranky today?
Well, I know you didn't wake up on the right side of the bed. I was the left side. So we can solve this proportion. We can do 5 times D. We can cross multiply 5 and D. 15 and 4. 5D equals 60. Divide by 5. And D equals 12. 15 times 4. Cross multiply. It's a lesson you missed.
What else am I gonna do? Just sit here? No,
Yes.
It's not fun.
Thank you. I liked it.
Remember, D does not look.
We go home.
Oh. Okay. Question on this.
Yes.
Okay. So these triangles are similar. Somebody help me set up a proportion.
No.
Great.
No.
Hold on, I gotta type this one. Okay, so we're gonna do 3 over, no, we're gonna do proportion, so it's gonna be 5 over 3. No, what am I saying? 15 over, no, 15 over 5.
Okay.
Equals
Yep.
A over 5.
Nope.
No,
Nope.
A over 3.
Yep.
That's what I said.
We can do 15 over 5 is equal to A over 3. Sure, we can do that. Is that the only way we can set it up?
No.
No.
I need to.
We can do 5 over 15 is equal to 3 over A too. That's fine. Now we can solve this. Okay, can we actually simplify this 15 and 5 before we start to?
Yeah.
We want to make our number smaller.
3 and 1.
3 and 1. So then, how do we actually solve this one? We do cross multiplying. 3 times 3 is?
9.
What's 1 times A? So A is? A is 9 is equal to A. 9? Was that one that bad?
Yes.
No.
I mean, I just read it.
Not really.
It's okay though.
Alright. On letter D. Okay. Somebody help me set up this proportion. We already know the triangles are similar. We're told they are in their instruction. Okay, Sarah.
24 to 120.
240 to 120 equals. Keep going. X over 70. Now we can use the location of our angles to help us.
170.
Okay.
Hang on.
Oof. Okay. We can use the proportion, the location of our angles to help us set these up well. X is between the two congruent angles, the 1 arc and 2 arcs, so 70, so those go together. Okay. Can we simplify 240 and 120?
Yeah.
Yeah, but first of all, we can chop off a 0. And then we can make that 2 over 1. Okay? So then we can cross multiply. Now their numbers are smaller. It's a little easier. What's 2 times 70? 140 equals x.
Can we go do A now?
Can we not do
Yes, we are going to go back and do a.
Yeah, and then screw E.
Okay?
Homework.
So going back to a, these two are parallel, right?
Yes.
Yeah.
Now, do we see a triangle
Yes.
and then a bigger triangle?
Yes.
Okay? So, can somebody have an idea of how we can set this proportion up? Amber?
28 and x are equal to each other, but x is greater. It's like 2 times now.
Okay, we don't know if it's going to be 2 times. Okay, that'd be triangle midsegment theorem. That'd be triangle midsegment theorem is that these are parallel, and so it's twice length, but we don't actually know that. Hey, what's up? Oh, you got some coffee for me? Oh, awesome. Want to give me a high five, Mason? Nice. Okay. So I've been the triangle proportionality theorem, but we actually don't know that this is a midsegment. Actually, we know it's not because this is 24 and this is 6, even if it doesn't look like it does. It is. It still is.
Bro,
Okay.
I got it.
Taylor, you got it?
Yeah, I think so. We were
Okay.
saying this is a proportion, right?
Yes.
Okay, so 30 over 24.
Okay, where'd you get the 30 from?
24 plus 6.
24 plus 6. The whole side of the big triangle is 30. So if we do the whole side 30 over the small side of the triangle, try that again. The whole side of the big triangle is 30 over the whole side of the small triangle is 24. Is equal to what over what?
And then x over
X over 28. So for all these others, we did the whole side of one of the triangles. We had to do the whole side. 24 plus 6 is 30.
First of all, let's make this small.
Questions on setups?
Why
Can I
is,
go home?
actually that doesn't matter. I was gonna say, why is 24 on the small triangle and 26 on the big one?
Yeah, that's just the way it is. Just drawn to scale, not drawn to scale. So yeah, 30 and 24, what goes into both? 6, and so it becomes 5 over 4. Cross multiply, 5 times 28 is 140. Is equal to 4x. Okay, and so divide by 4 and x is 35. Was that as bad as we thought they were maybe?
Yes.
Okay, I do. Can we like not do e?
We're doing E just because you asked.
Okay.
This is actually one of the easier ones. Should be easier than B.
Okay. E we just have decimals, right?
Yeah.
And then for E we can both find both x and y.
Yeah.
We have to set up 2 different problems to find x and y.
Yeah.
Yeah.
No.
No. Sure.
I
Wait,
think
could
we
you
should.
do a proportion and then set that proportion to a proportion?
Okay. What I would do on this one is I would start with the known. 12 over 16.8. So you can do either one on top, we don't really care. Let's say we do 16.8 over 12. That could equal what over what?
Y over 21.
Okay? Try the other way around.
21 over Y.
Because I set up, okay? So I would do this and solve for y. Then I would go through and I'd do another one, and I'd use the same proportion I already have, instead of using the one with y, because we just found that, and do another one with x, and do x over 8. And I'd solve each of these individually. Does that make sense?
So we're not going to do it?
I'm not going to make you do it.
Oh, thank God.
Not yet. Got a whole other thing to do.
No, you didn't go. You might be told.
No, we're going to do one more problem.
Whoa.
Let's do G. I shall have G.
Oh, there's F. We're going to do F.
Oh,
Okay.
F in the chat.
can you like never do that again?
Okay, so, actually we're gonna talk about F, and then we're actually gonna do H. We're just gonna talk about F. AB is parallel to DE. So we can figure out some congruent angles here. What angles could be congruent here?
20 and 12. No.
Okay, C and C. What other angles can be congruent here if these two lines are parallel?
A and B.
A and E, alternate interior angles, parallel lines cut by transversal, and then D and B. Could that help us know what to set up here? Now we're supposed to find the length of DC, so we could call that X. From there, could we set this one up? Cool. Okay. Let's continue on actually to H, so we're actually gonna do H. Okay. That was our short little, hey, let's talk about F. Now let's actually do H. Okay. Gucci. Okay. So we're asked to find the measure of RT. Do we know the measure of RT at all? No. Okay. But we can solve it. Who can help me do this one? Anybody have any ideas on how we can do it?
You can do,
Okay, go ahead, Graydon.
8 over 12.
Okay.
And then, 4. I'm almost there. I'm on lock.
Hey, no, you're raising your hand, trust me. Okay, Sarah.
You just let it equal 10 over x.
Okay, 10 over x. What's x represent?
As r.
R to t. We know the small triangle has this length of 10. The whole triangle, we don't know it, so we call it x. We can set that up. Okay, Daffy. Okay. 10. 8 over 12, can that simplify?
Yeah.
So what over what?
1.
2 over 3.
Yeah.
This makes our life a little easier. Now we have 2 times x is 2x. 3 times 10 is 30. Divided by 2, and x equals 15. So the length of RT is 15. Now what would we do if we were asked to find ST?
Subtract it from 10.
Subtract. Or subtract 10 from that.
Which would then be 5.
Question on that? Fun.
Oh, no.
We're using ratios!
Just like
You were getting them.
Oh, you don't even know.
Stop judging me, though. Yeah.
Yeah, merch. Not the stuff, like I'm talking merch.
Okay. Have fun here, Mr. Council.
iPhone XS.
I'm a little upset.
I got a little upset.
Like the 8th time today, Dave.
Why are you upset?
Because you have like the one version better.
Okay. I know that was a competition. So don't do,
Everything's a competition all the time.
okay, so I always win. Don't do numbers 1 and 12. And then I have a note on 15 and 16.
What you got?
And 16?
Don't do it.
Yep, on 15 and 16. So there's a note on 15. So on number 15,
What you got?
angle B is congruent to angle H. And on 16, angle S is congruent to angle B. Yep. B as in Valentine.
No, bro.
That's not
you
no
didn't get
prize.
me.
I'm gonna be single again.
Were you not single last year?
Go on. She said again.
Oh.
I think I haven't been single for Valentine's Day once. That's funny, but I don't remember asking.
I'll say that it's factual. It's a little rude. You guys are my favorite third hour honors geometry class I have ever had. Yeah. I'm a nice guy.